Thank you, Volker. Thank you for having me. As I mentioned, so yes, please submit questions, as I go along in the chat function. But if you have clarification questions, please don't hesitate to interrupt me as we go along. I will let Volker moderate that. Title is Emergence of a Platform Trap. My co-author's here, so hopefully we can field all the relevant questions. The motivation for the paper is fairly simple. It's the idea that if you look around, any business today really can't avoid working with platforms. So if you have a hotel, you have to be on booking.com or similar websites. If you have a restaurant, it's difficult to avoid being on Uber Eats or DoorDash or others. If you're trying to sell stuff online, it would be virtually impossible to avoid being on Amazon or whatever the equivalent is, depending on the geography. So it is true that being on platforms offers great advantages, right? The idea of being on large platforms, let's say marketplaces, is that you have access to lots of consumers. But there's also a very real concern, increasingly so, that being on dominant platforms may carry some issues. So over time, platforms tend to exploit their sellers. And that can take many different forms. We can observe that over time, platforms may increase their fees. They can start saying, well, the fees are the same, but now you have to advertise in order to be at the top spot, because if you're not on the first page, then nobody clicks through to the second page. So you essentially have to pay more. They can also design their algorithms in ways which intensify price competition between sellers, which obviously is not great for sellers. They can make subtle design changes that essentially make consumers be more dependent on the platform, and they weaken the relationship between the sellers and their customers. So the interesting question is, I think by now most people, like including sellers, know this. So if you know that at some point you're going to end up exploited by a platform, why would you participate in the first place? And this is that's the main question we want to address in the paper. One thing I want to mention here, as I go through the talk, I think it's most useful to keep in mind the example of marketplaces like hotel, booking.com, Amazon, or something like that. I think that's a good primary example. But the idea applies to other platform settings as well. You can think about individuals joining social networks like Facebook or Instagram, or for example, news organizations deciding whether to participate by signing deals on social media companies or on search engines. So the theory, what we do in the paper is provide a dynamic theory of what we call platform trap. And the idea, in a nutshell, is that agents voluntarily join the platform. So nobody's forcing them, but at the end, they all end up worse off because of this participation. And key conclusion is at least some of the agents would have been better off if they could have agreed and committed ex ante to not basically boycott the platform, or if the platform wasn't there. So in the case of, if you think of it, to translate this in the context of a dominant marketplace, the idea is that participating sellers, so the more sellers participate, they start drawing more buyers on the platform as the sellers join the platform. And as this happens, the crucial mechanism that we rely on in the paper is that more buyers participate on the platform. That draws buyers away from, say, the seller's direct channels, which means the seller's outside option of not participating on the platform is getting worse. So as this happens, the sellers who have managed to stay out, actually, they're increasingly incentivized to join the platform. And as they do so, the outside option gets even worse. And as a result, everything unravels and all the sellers basically feel like they have no choice to join the platform, which of course also enables the platform to exploit this by raising the fees to sellers. So fundamentally, this is a collective action problem. Essentially, like if sellers could coordinate like from the very beginning, they should all coordinate and commit not to join the platform when the platform trap exists. But of course, each of them acting independently, they find it individually attractive to join the platform. And as they do so, it makes not joining the platform a less attractive option for everybody else, and then everybody else ends up joining. So key point is platform ends up exploiting the lack of coordination between agents. The model that I will show you, so I will show you the baseline model and the results, and then just give you a sense of the extensions. But as Volker mentioned, I would like to just mostly focus on the intuition, not so much on the math. The idea is like rational. So the model doesn't rely on any kind of irrationality. Agents are fully rational, forward-looking, and so we're not assuming any miscoordination. The key point is so the key ingredient is. Let me just put this here. The key ingredient is that agents make sequential decisions, and agents who have to decide whether to join or not early can be pivotal in the sense that their decision determines whether or not subsequent agents join. And in this context, once the platform attracts a sufficient number of early agents, you can think of this as being critical mass. So once you've attracted a critical mass of agents, then later agents are no longer pivotal and the prices can then increase. So the idea is like the platform can engineer this platform trap by setting low prices to early agents to get to this critical mass, and then you can increase prices for later agents. Another key ingredient is like if you're an early agent, let's say you're a pivotal agent, you understand that this is happening. Again, agents are forward-looking and rational, but the reason you join is that you expect that even if you don't, the platform will adjust its prices in order to attract future agents. So in some sense, it's like you really have no choice but to join. That's the trick, quote unquote. All right, so here's what the baseline model looks like. There's one platform, n active agents, and we can also assume there's n0 inactive agents. And the reason this matters is because there will be an externality on these inactive agents. So the payoffs, key assumption here, there's two types of payoffs. There's the payoff to agents. There's utility for agents, which is called B of N. And you can think of this as being the network effect from being on the platform. So if small n agents, so small n is the number of agents that join the platform. If small n agents join the platform, then agents who are on the platform derive utility B of N, which is weakly increasing as a standard network effect. And then the other piece is the utility of being outside the platform, and that's U of N. And we're assuming that is the key assumption is that it's weakly decreasing. So I would say this is sort of the key differentiating feature between this model, this paper, and say traditional standard network effects literature. And that's the idea that as more agents join the platform, so small n increases, it's not just that the utility on the platform increases, but it's also the case that the utility from staying outside the platform is decreasing. So in some sense, the platform is also undermining, by attracting more agents, it's also undermining the outside option. And again, you can think of this in the context of marketplaces. As more sellers join a marketplace, of course, becomes more attractive to buyers, but then more buyers go to the platform and then start searching on the platform first. That means in total, there are fewer buyers who go, let's say, who go to search to sellers' direct channels. That's what we have in mind. So that's this assumption. And one more thing here, given the generality of these functions, so B of N and U of N, we don't have to necessarily assume that when an agent joins the platform, they give up on their direct channel. You can think of like two possibilities. When the agent joins the platform, they give up the direct channel, but it's also possible they may keep the direct channel. So you can subsume all of this in the B of N and U of N function. So if the agent, for example, joins the platform but keeps their direct channel, you can think of B of N as being the sum of the payoff on the platform and the payoff that the agent keeps getting in the outside channel. All requiring, again, is the fact that B of N is increasing and U of N is decreasing. In terms of timing, we're going to say there's one period, but there's n stages. So it's a sequential game, again, with n agents. In each stage, one agent receives an offer, which is P, a price, from the platform, the price to join. then each agent observes, crucially, each agent observes the decisions of previous agents, so previous agents that have received offers, and then makes their decision whether or not to participate accordingly. And then all payoffs are realized at the end of the period. A couple assumptions. So first of all, this is not an assumption. It's a consequence of the assumptions before on B of n and U of n. We'll denote by delta of n plus 1, so B of n plus 1 minus U of n. You can think of this as the propensity of the next agent to join the platform, or the willingness of the next agent to join the platform if n agents have already joined the platform. So if there's already n agents of the platform, if I'm agent n plus 1, if I join, my utility is going to be bn plus 1. If I don't join, it's U of n. So delta is just the difference between the two. Obviously, this can be positive or negative, but of course, we're going to require that delta of capital N. So if all agents have joined the platform, all active agents have joined the platform, we will assume that that all agents are happy to be on the platform. If all agents have joined, or if they expect all agents to join, then each individual agent actually wants to join the platform, because otherwise it just means the platform never has any shot at attracting any agents away from the outside option. So we've assumed both, so B is weakly increasing, U is weakly decreasing, but we're going to assume that there's at least one point at which U, the function U, is strictly decreasing, right? So like it has to drop by at least some amount, somewhere in between the values of 0 and n minus 1. So that also implies that delta n plus 1 is greater than delta of n for some n between 1 and n minus 1, which means at some point, some agent, like having an extra agent, is really helpful in increasing the marginal propensity of agents to join the platform. So in terms of interpretation, like I said, we have this model in which there's one period and n stages. Now you can interpret this in one of two ways. You can say, well, actually this is just one of many possible periods, and you can put discounting across periods. As long as we assume that agents have no switching costs, then there's going to be no linkage across periods. And you can think of our game as basically you can repeat the same game across many periods, perhaps with different capital N, so different total numbers of agents. But then everything within each period is the same as I'm going to describe. Or you can interpret the model as basically being, this is the full timeline. So the various stages, the n stages, is actually all the periods in the game. There's no discounting. And then in that case, we would assume that agents are locked in across periods. So once they decide to join or not to join, then they're locked in. Yeah, I think either interpretation works. Given that agents are symmetric, the order of offers, the order in which platform makes offers to the various agents doesn't really matter. Commitment, so this is important. The platform cannot and actually would not want to commit to prices, meaning it will adjust prices as we go down the sequence. In particular, for example, if agents if some agents don't join, then the platform can adjust prices to make it more attractive for subsequent agents to join. And of course, agents do take that into account when they decide whether or not to join. They understand that the platform will adjust their prices, and that's a key part of the mechanism, right? So I know that even if I try to hold out and I don't join, I know that the platform can still adjust and attract later agents. Okay, so in terms of, so there's this idea which plays an important role in the model, and especially in the proofs, and that's of pivotal agents. And I think that's quite intuitive. It's certainly something platforms think a lot about. And so pivotal agents are such that so at some point in the sequence, especially early on, so early agents are the ones who are most likely to be pivotal, in the sense that it is necessary to attract those agents in order to be able to profitably attract any subsequent agents, right? So this all depends, of course, on the shape of the functions, delta, B and U, and delta. So for example, if delta of 1 is greater than 0, so this means even if there's no other agents that have joined the platform, a single agent is actually willing to join the platform, even if no other agents have joined the platform, this means no agent is pivotal. It means the platform can just like attract one agent, and that agent derives, positive benefit from being on the platform. Well, then the job of the platform is very easy, right? And each agent knows that my decision doesn't have any influence because basically like the platform can attract all the other agents. In this case, so this is the best case for the platform, it can extract maximum, so all the utility from agents. So the platform extracts delta of n from all the agents. Each agent knows that everybody else is going to be induced to participate, so they're willing to pay up to delta of n. So this is B of capital N minus U of capital N minus 1. At the very other extreme, imagine now that the platform needs all agents to join, so all agents to join before each agent is actually happier to be on the platform than being in the outside channel. So this is saying delta n minus 1 is delta of n minus 1 is smaller than 0. Again, in other words, if the platform fails to attract even one agent, then it's not going to be possible to profitably attract any of the other agents. That means all the agents are pivotal. So like each agent knows like, if I don't join the platform, nobody else is going to join. Well, in this case, the platform has to work harder. So it basically means everyone's pivotal, and the earlier agents are the most pivotal ones. So then prices are going to be lower for earlier agents, and then they progressively increase. So the optimal prices are given here. So agent K in the sequence gets a price of B of capital N minus U of K minus 1. And recall, U is decreasing in K, which means this price is increasing. Again, it's quite intuitive. The price will increase as you attract more agents. So in terms of baseline results, the key result in the baseline is contained in this proposition. So it is possible. So there's this condition which ensures that the platform can attract all agents to participate. Now, in general, it's possible, again, depending on the shape of the functions, it's possible that there's some pivotal agents, no pivotal agents, or that all agents are pivotal. Whatever case it is, the prices for pivotal agents are as given here, and for non-pivotal agents is always going to be delta of n. So these formulas apply regardless of how many pivotal agents there are. And the key implications is that if agents participate, if the platform is able to attract agents to participate, so it will attract all agents to participate. And if that is the case, all the agents are weakly worse off with the platform, i.e., the net utility resulting from all agents participating on the platform is less or weakly less than what they would get if they could collectively boycott the platform, or if the platform didn't exist. And actually, some of them are going to be worse off. Some of the agents are going to be worse off. So by the way, for this result, again, note that we do allow, of course, the platform to subsidize agents. And this is key, right? If, like I said, some agents are pivotal, it is quite possible, which is natural. We know this from previous literature with network effects, and certainly shows up here. The prices for some agents might be negative, right? So you may need to subsidize some agents, get to critical mass, and then you increase prices and make profits on future agents. Now, we also look at a version of this results. For example, we can assume that for whatever reason, it's not possible for the platform to subsidize agents, perhaps because it leads to moral hazard, or it's just very difficult for a platform to subsidize. In that case, we get a slightly different result. It still relies, so the prices still rely on how many agents are pivotal. However, what changes is the condition under which the platform can attract all agents. So note in this particular case, the condition for the platform to be able to attract all agents is simply B of n greater than U of 0, which actually is the efficient condition for the platform to attract everybody. So B of n is the utility that each agent gets when all agents participate. U of 0 is basically the utility each agent gets when none of them participates. So if the platform is efficient, then we're able to profitably attract all the agents. And then prices are very similar. So the expressions of prices when agents are pivotal or non-pivotal is the same as before. However, the common denominator is that once again, whenever the platform attracts all agents, they're all weakly worse off with the platform. So they will still benefit from boycotting the platform. So just to interpret the main result here, basically like this is what we mean by platform trap. The platform, so under certain conditions, the platform is able to attract all agents. When the agents join, they make the outside option less valuable, which brings more agents onto the platform. And consequently, I mean, in this baseline setting, it's a pretty extreme version of a platform trap in that all agents are weakly worse off and some are strictly worse off. And again, this relies on a collective action problem. This just basically this is kind of giving some intuition as to why the agents are weakly worse off. It's basically like each individual agent, if they're non-pivotal, they're basically left with the utility they would get if they were the only agent to stay outside the platform. And if they're pivotal, they do better than this. But in any event, this is definitely not as good as if all agents stayed outside the platform. Now, you can also ask the traditional question that people have asked about platforms: are they efficient? So, do we get are platforms able to attract agents when they're efficient? So, what's interesting is if platforms are able to subsidize. If the platforms are not able to subsidize, then, like I said, the platform only attracts agents when it is efficient to do so. However, if the platform can subsidize, we get perhaps the not surprising results that it is possible for the platform to be viable, to attract all agents, even if it is inefficient to do so. Now, note this, so efficiency and inefficiency is from a total surplus perspective, whereas in this particular paper, we're more focused on the platform trap notion, and that basically is focused on whether or not agents are worse off, which is, again, different from the usual focus of the network effect literature. So there's a number of extensions we do in the paper. Again, this is work in progress. We're actually currently adding more results. I think the stuff we're mostly focused right now is having a nice model with platform competition. So I can show you some results, some limited results I think are pretty intuitive. But we have a few other extensions. So I'll go through these relatively, let's see, I have like about 8 minutes. So I'll go through these relatively quickly just to give you a sense of what these extensions do without going too deep into the modeling. And by the way, the goal of these results is to sort of explore the limits of this very admittedly extreme results that we obtain in the baseline, i.e. the fact that all agents are worse off with the platform. So what we mean by limited information, instead of assuming, as we did in the baseline, that each agent observes all the decisions of previous agents when they get to decide whether or not to participate, imagine now that each agent observes all the previous prices that have been offered, so the previous agents, but they don't observe their decisions. So once we do that, now we're back to the standard network effect issue of multiple equilibria. So in the baseline model, given that everything's sequential, that each agent in the sequence observes what every previous agent has done, there's no multiple equilibria. Everything's nice and unique. Now that agents don't observe the previous agent's decisions, we have this issue of multiple equilibria. So we do something which is fairly standard in the network effects and platform literature. We look at the best equilibrium for the platform and the worst equilibrium for the platform. So we want to get a sense of what's happening in terms of platform trap and these two extreme equilibria. But of course, there are many other equilibria. So as it turns out, in the best equilibrium for the platform, well, the platform is able to extract maximum price, so delta of n. All agents participate, but they're all worse off with the platform, perhaps not surprisingly. More interestingly, if we look at the worst equilibrium for the platform, meaning agents will always coordinate on the worst possible equilibrium for the platform, in this case, the platform has to resort to what's called the divide and conquer pricing strategy, in meaning you have to you start with like low prices to attract the first agents, and then as you attract more agents, you increase prices. So in this case, there's a split. So some number of early agents are actually better off with the platform, and some number of agents which come later are going to be worse off with the platform. So there's a very nice cutoff in the middle. then you can go even further. So we can now say the agents don't observe neither the decisions nor the prices of the previous agent. So each agent only observes their own offer. So in this case, again, there's you still have multiple equilibria, except that the equilibria are a bit different. So the best equilibrium for the platform is the same as before, as I just described. And the worst equilibrium for the platform is actually now worse for the platform. So in this case, it turns out all agents are weakly better off with the platform. All active agents are weakly better off with the platform. So notice I didn't mention, so I mentioned at the beginning, we also have like a mass number of agents, N0, which is inactive. They don't play any role in the model except to remind us that if the platform exerts an externality on the outside option, well, if there's a bunch of inactive agents who never even consider joining the platform, there is an externality on them. So as the other active agents join the platform, these inactive agents basically suffer as a consequence. So if we take their welfare into account, it's like, well, that actually makes the plot, so that always creates an additional efficiency loss, or welfare loss from the platform attracting other agents. This was limited information. The other thing we look at is the case of limited rationality. So up to here, agents are fully rational, fully forward-looking. There's no issue. Now we can assume, so what happens if we assume the agents are myopic, meaning they just look at what previous agents have done, and they just ignore what they just ignore completely future agents. So they just basically assume like the only thing I'm going to get is all the agents that have participated, like before I decided. In terms of pricing, the solution is going to be the same kind of divide and conquer pricing from the platform's perspective, and we still get the same cutoff. So we still get this cutoff. So some early agents, so some number of early agents are better off with the platform, and then all the remaining agents that come later are worse off with the platform. We can also explore the implications of pricing flexibility for the platform. So remember, this was a key ingredient in the baseline model, in the sense that the way, like a key component of the platform trap is that even if agents, so if each individual agent understands there's a possible platform trap, but like part of the reason they can't help themselves and join is because they understand that the platform is able to adjust prices to future agents, or to subsequent agents, to make up for the fact that I'm not participating. So it's basically like, yeah, I will participate because I know the platform is going to adjust prices later on. So you can ask the question, well, what happens if the platform now, if we limit the platform's pricing flexibility? So the most extreme version of that is the platform now has to set a unique price. So once you observe this price as an agent, you know that the platform is no longer going to be able to adjust the price later on, depending on whether you join or not. Well, perhaps not surprisingly, in this case, you actually get participation on the platform only when it is efficient, and actually agents are indifferent between the platform's existence and the platform not being there. So in this case, the platform is unable to hurt, quote unquote, the agent. So there's no platform trap. However, so this is a very extreme. So this is a very extreme assumption, right? So this just takes away all the pricing flexibility from the platform. However, we still go back to the maximum platform trap as long as actually all we have to do is to allow the platform to change price only once. So remember, in the baseline model we place no restrictions on the pricing flexibility on the platform. It actually turns out that the only thing we need is to allow the platform to change its price only once, or to allow it to commit, instead of to one price, to a pricing function. So the platform, if we allow the platform to say ex ante, like, here's a menu of prices, and I'm going to charge. So here are the prices that I'm going to charge, depending on how many agents end up joining at the end. But the platform has to commit with that up front. In both of those cases, we still get basically the baseline platform trap. We can also get a limited version of the platform trap if we introduce some heterogeneity across agents, which is perhaps not surprising. So a key driver of the very extreme results, of course, in the baseline model, that the platform is, extreme platform trap where everybody's worse off, is that all agents are the same. if there's heterogeneity, it stands to reason that the platform has to leave some more surplus to the agents, which means at least some agents may be actually better off with the platform. And another way or another reason that the platform may need to leave more surplus to the agents is simply by assuming that there's some negotiating power by the agents. So in the baseline model, we assume the platform has all the negotiating power in the sense that it makes take it or leave it offers to all agents. We can look at a more complicated version in which each agent bargains with the platform. Agent has bargaining power alpha, platform has bargaining power 1 minus alpha. It's more, the analysis is more complicated, more involved, but basically what we get is that it's quite possible that early agents, so if the bargaining power of agents is sufficiently high, early agents will actually be made better off by the platform's existence. Later agents will be worse off. Of course, if agents have maximum bargaining power, then basically like all agents are weakly better off. And then finally, we look at platform competition. So I'll just show, this is the one clean result that we have. We're still working on, more general versions of this, but the one clean thing that I can say is the following. Imagine there's two platforms. Each of them has their own benefit or network effect function. So B1, which is, we assume is uniformly greater than B2. In other words, platform 1 generates more, like stronger network effects at any network size than platform 2. And then we have to assume that the outside option now depends on both the number of agents that join platform 1, the number of agents that join platform 2, say N1 and N2. And we assume, so this outside option is decreasing in both arguments. Under these conditions, and assuming the platforms cannot subsidize, then we get this very nice and clean result that basically platform 1 will get all agents to participate if and only if platform 1 is efficient, i.e. it's better to be on platform 1 for all agents than for all of them to stay out. And then we actually get a clean condition here in terms of whether there's a platform trap or not. If the network effect that one agent can get on platform 2 is enough to be better than the outside option when all agents stay out, then actually all agents are weakly better off with the platforms. So what this means is like, if the network effect created even by the weaker platform is such that one agent is enough to dominate the outside option, then it is perhaps not surprising that actually agents end up better off with the platforms. Like, and the fact that you have so especially the weaker platform exerts sufficient disciplining force on the stronger platform such that all agents end up better off. If that's not the case, so if the reverse is true, B2 of 1 is smaller than U of 0, 0, then all agents starting with the second agent are actually worse off with the platform. And the first agent may be better off or worse off with the presence of the platforms than if the platforms didn't exist or if the agents boycotted them. So the key conclusion here is that, of course, the presence of a competing platform is able to discipline the winning platform, which means we're more likely to see at least some agents being better off. However, of course, that depends on how close or how much value the inferior platform adds relative to the outside option. And we still get, like, overall, we still get this mechanism in which early agents are the ones who are more likely to be better off with the platforms. Later agents are less likely to be better off. So it briefly concludes, again, it's a dynamic model. I think the key here is that we show that a platform trap can emerge even, like, we assume agents are rational, they're forward-looking, there's no sort of baked-in assumption about agents not understanding the mechanism. An interesting implication of what we've done here, especially if we take seriously this idea that platforms not only generate network effects on the platform, but they undermine the outside option, is that if we're trying to evaluate whether or not platforms decrease or increase surplus, well, if you're only looking at the status of the platform today versus the outside option, that won't tell us much. So that's not going to be enough, right? What you really want is to compare the utility that the platform gives to everybody today versus the utility they would have had on the outside option if the platform hadn't even existed, right? Which is of course much harder it's much harder to measure. So it would be like a bit like, let's look at the I don't know, the net utility that DoorDash creates to restaurants today versus a counterfactual in which DoorDash didn't exist and the restaurants had to attract everybody on their own direct websites, which is of course, again, it's much harder to measure. There's a couple other avenues in which one can extend the analysis we've done here. I think we're planning to explore both of these. So the idea is to sort of become a little bit more sophisticated about platform traps. So there's a couple of different things. One is to allow agents to make platform-specific investments that increase the utility agents get from the platform, but at the same time, lock the agents into that particular platform. And the second one is specific to marketplaces. We could also introduce this a mechanism through which sellers on a marketplace, agents on a marketplace get commoditized. In a sense, for example, let's say competition on the marketplace is more focused on price than if they were competing outside the marketplace. With that, let me stop here, and hopefully that generates some questions. Again, comments are most welcome. This is the first time either one of us, so either me or Julian, has presented. So that's when comments are most useful.